Good morning. This is your Stats Sensei, Mr. Spensei, and this is a warm-up on the inverse normal. We're going to be focusing on z-scores and on actual values in both in this video. So, for the following scenarios, draw the graph, give the calculator commands, and answer the question, being certain to box your answers. So, our scenario: battery life. The lifespan of a rechargeable battery follows a normal distribution. We need to know that because if it's not normal, we cannot use um, normal approximation. So a battery is in the top 5% of the lifespan. I highly recommend that you put an X and go, oh, 5% is on the top part, so it's above it. So let's go ahead and draw our graph so that it looks like this. And it's asking for the associated z-score. And remember, all z-scores have a mean of 0 and a standard deviation of 1. So we're going to note that off to the side. Mean of 0, standard deviation of 1. And we're looking for the top 5%. All right, please remember this goes to positive infinity. So if we're looking at the top 5%, we're looking at the right-hand side of the graph. And so we're going to go inverse norm is where we're going to go on the calculator. So inverse norm. And in case you forget what's on the calculator, you just go ask it what it says. So it says second vars, inverse norm. And the very first thing it asks for our area. So the very first thing it's asking for is that probability, which in this case is 0.05. And since it's a z-score, it'll have a mean of 0 and a standard deviation of 1. And as a way to remember that, here's what the calculator is asking for. Probability, mean, standard deviation, or PMS. All right? So 0.05, mean of 0, standard deviation of 1. And remember, when we look at our picture, oh, we're on the right-hand side, so make sure we've chosen the right-hand side. And we get 1.6448. Now, not all the calculators will give you the option of choosing the right-hand side. So for this problem, I'm going to do a quick review on what to do. All calculators will do the left-hand side even if they don't say so. Well, 1 minus 0.05 happens to be 0.95. So if you're having to come from the left, all right, if your calculator is forcing you to come from the left, you're going to go second vars, inverse norm, and you're going to change your area, your probability to 0.95, and your calculator will have the left. And so you still get the same thing. And that makes sense that we'd have a positive z-score because we are above the mean. Since we're above the mean, we should have a positive z-score. All right. A battery is in the lowest 20% of lifespan. So once again, we put our X. We go, oh, our 20 is below that. So now we're going to draw a picture. And they're asking for the associated z-score. And all z-scores have a mean of 0 and a standard deviation of 1. So this right here is going to be 0.20. So we're looking for this z-score right there. Once again, we're going to go to the inverse norm on the calculator. The very first thing it's going to ask for is the probability, which is 0.20. It'll have a mean of 0 and a standard deviation of 1. That's what the calculator is going to ask for. So second vars, inverse norm, 0.2, mean of 0, standard deviation. Oops, that'll work. 0.20, mean of 0, standard deviation of 1. And if we look at our picture, we're shading from the left, so we're choosing the left on this side, and all the calculators will do that. And we get a z-score of negative 0.8416. 0.8416. And once again, what we plugged into the calculator was our PMS. All right. Now, it makes sense that this will be negative because our z-score is below 0. So if it's less than 0, it should be negative. All right. What z-scores are associated with the middle 85%? All right. So middle 85%, we're still centered on 0 because it's a z-score, and we're looking for this area right here that I just shaded to be 0.85. All right. So once again, we're going to go inverse norm. It's going to ask for the area. which we're going to say is 0.85, mean is 0, standard deviation of 1 because it's a z-score. Once again, we have our PMS. Now, my calculator will work with the middle. Not all calculators will, and I'll show you how to address that. So second vars, inverse norm, area is 0.85, mean is 0, standard deviation 1, and we're going to choose center because we wanted the middle part of that graph as we showed here. All right, so it's choosing center. Press enter, and we end up getting two z-scores because essentially we're looking for this lower z-score right here, and we're looking for this upper, and we end up with a negative 1.439 and a positive 1.439. So let's box our answer. Should have done that up here. So we have negative 1.439 and a positive 1.4. You know what? I didn't have enough room. Let me lower that down. 1.4393 and positive 1.4393. And because it's symmetric and centered on 0, it's going to be the same value. All right. Because we're centered on 0 and the normal curve is the same, it'll be centered on 0. Now, I said not all calculators will do this. And if yours works from the left only, you're going to have to do a couple other things. You're going to need to go 1 minus 0.85 and divide that by 2. And that will get you the lower bound. And the reason you're dividing by 2 is you have two tails. So here we go. Second vars, inverse norm, parenthesis, 1 minus 0.85, close the parenthesis, divide by 2, and that's coming from the left. And you get the negative 1.43953. Because it's symmetric, you just need to change it to a positive, and you'll have both of them. Okay? So, scenario, test time. The time required to complete an exam is normally distributed with a mean of 120 and a standard deviation of 10. I'm going to write this off to the side so I don't forget it. So mean is 120, standard deviation is 10. All right, what percentage of students will take at least 130 minutes to finish the exam? Well, they're asking for what's the probability that X will be greater than 130 minutes. So if I draw my picture of this, we're sitting at a mean of 120, and we're up here at 130. This is my X, and I'm looking for that area. Now remember, this goes to positive infinity. Well, remember, if they give you an area, a percent, or a probability like they did above, you're working with the inverse norm. If they ask you for an app, if they ask you for an area, percent, or probability, you're going to use norm CDF. So they're asking me for what this probability is or percent. So consequently, I'm going to have to do a norm CDF. So this is a norm CDF. And let's go see what the calculator asked for so that we know the information. Second vars, norm CDF, and our lower bound, well, lowest part of our shading was 130. The upper part of our shading was 9 raised to the 99th. And we have a mean of 120 and a standard deviation of 10. So we'll plug that in. I'm going to write that stuff down the way I'm supposed to. So this is 130, a positive infinity, mean of 120, standard deviation of 10. That's exactly what the calculator asked for. And remember, this is our LUMO, which is lower, upper, mean, standard deviation. And we end up getting 0.1586. All right. The next one, 10%. Well, here they gave me a percentage, so it's like, probably going to be working with the inverse norm. 10% of students will finish the exam in less than how many minutes? They did not ask for a z-score, so I'm using my actual value. So I'm going to need to use this. So my my mean is 120. Well, anytime they give me a percent, I always put an X and I go, oh, less. All right. So that means the 10 is down here because it's less. And remember, we're always dividing percentages by 100. So this is the area I'm looking for, 0.10, and I'm looking for this X value. So because they gave me the area, because they gave me the percent, I'm going to be doing in a inverse norm. And as we saw before, the very first thing they're going to ask for on the inverse norm is the area, which we know is 0.10. They're going to ask for the mean, which our actual mean is 120, and our standard deviation in this case was 10. And so this is our probability or percent. This is our mean. This is our actual standard deviation. So there's our PMS. Get that stuff typed in the calculator. And if you notice, we're shading from the left-hand side, and I'm going to put this as a negative infinity. And we end up getting 107.1844. 107.1844. So there's our answer. Okay. All right. And this is actually in minutes. We should probably label that. All right. 80% of the students will take more than how many minutes? All right. So we put our X and the 80. Oh, they say that's more. So that's above it. And remember, we're dividing by 100 because it's a percent. So 80% of students will take more than how many minutes? Well, we know our mean is 120, but 80 is above it, which means I'm shading from this way. Well, 50% is halfway. We want to go more than halfway. We want to go over halfway. And this area right here is 0.80. And we're looking for this X value right here. All right. So inverse norm, because they gave me a percent. The very first thing the calculator asks for is the area, which is 80 divided by 100, which is 0.80. It's going to ask for my mean, which is 120. And our standard deviation for this problem happens to be 10 because they gave this up to us up here. Standard deviation is 10 minutes. And that's our PMS. Second vars, inverse norm, area, 0.8, mean, 120, standard deviation, 10. And, oh, I got to be careful. Even though I crossed over, we started from the right. So make sure that you're shading from the right. And we end up with 111.5837 minutes. So 111.5837 minutes. Now, if your calculator doesn't do that, you're going to have to go 1 minus 0.80 and find out that this is 0.20. And I'm going to do that real quickly. So second vars inverse norm, 0.2. And now I'm going to make it come from the left because it'll give me exactly the same answer, 111.5837. 70% of the students will take more than how many minutes? Well, once again, I put an X. And 70% is above it because it says more. So 70 is right here. We're going to divide by 100. All right. So once again, 120. We know our standard deviation is 10. Now let's think about this. I'm above it, so I'm shading. All right. Shading this way. So this right here has to go over halfway because halfway is 50%. So this is 0.70. So in this case, inverse norm, 0.70, 120, and 10. That's our PMS. Second vars, inverse norm, 0.7, mean of 120, 10. And notice we shaded from the right, and that gives me 114.7559. 114.7559 minutes. Again, if your calculator doesn't work that way, then you're going to have to go 1 minus 0.70, which gives you 0.30. All right. And you'd plug in 0.30 and you would get exactly the same answer. Let's go ahead and do that real quickly. So second vars, inverse norm, parenthesis 1 minus 0.70, and we're shading from the left, and we get 114.7559, which is exactly what we had. All righty. I sure hope that helps. Look forward to seeing you on the next one. Thank you.